So, how do we estimate time for our project, given there's a lot of uncertainty? I get this all the time, and if you have an activity where it could take a day, it could take 10 days, what do you use as a reference point? What do you use for your estimates? You don't want to be too optimistic, you don't want to be too pessimistic, and you want to convey to the client that, hey, you've put some thought into this. This works equally well for time and cost. I'm just going to use a time-based example, but I'm sure you can extrapolate the concept. What I'm going to be talking about is a 3-point estimation technique. Rather than giving 1 point, and the 1 point we normally give is, that's a pretty dodgy looking X, is the average or the mean. We usually say, look, most of the time it takes 3 days. So we give that point and we run by it. But as you can see, whilst the distribution is around this central tendency, what about these cases? Have we accounted for those? No. So the 3-point estimation technique says, instead of using this model, and if you're using this model and it works, that's fine. We do go into time estimation and there is a line of regression. So basically the graph is that the more time, or I'll use the word effort because that's realistically the metric, the more effort you put into it, the greater the accuracy of your estimate. And you'll get a curve that goes like this. Okay. So very early on in the project, you probably won't get a strong estimate because it's concept, you're only putting a few hours into it just to get a rough number. As you go through, have a detailed work breakdown structure, more effort has gone into the development of that estimate, so the accuracy is greater. There becomes a point where, in economics we call this the law of diminishing returns. There becomes a point where you start putting more and more and more effort in, but it's only an incremental, marginal, if that, increase in accuracy. So for a lot of people, we say, look, we've got enough confidence here, let's do the project. For other projects, shut down in oil and gas and mining industry are a great example. We tend to venture further down this curve because we need a greater confidence interval. We need more confidence in our accuracy. So, one way to bring your estimates up without spending too much time and effort is the 3-point estimation technique. I'm just going to quickly rub this off so we can have a fresh slate. Okay, 3-point estimation technique says, instead of just taking the average, let's take 3 points. Pretty self-explanatory. And what we're going to take is what we're going to call our optimistic duration, the best case. If we smash this out, if we do it as quickly as possible, what is the quickest we can do it in? We're going to take our average, which I'm going to call most likely. So 50% of things go our way, 50% of things go against us. What should it take? And we're going to take our pessimistic, our worst case. So if everything goes against us. Quick example, let's say we're digging a trench. So we've got a 100-metre trench to dig, and best case, if everything goes our way, we can get this trench done in 1 day. However, history has taught us that 3 days is probably our most likely. Worst case scenario, well, I mean, I could go crazy with this, but let's say 12 days. And that's assuming that things don't go our way. We have a really bad experience. In this example, it's probably a good one because as you're digging, you might hit uncertainties, rocks, and so on that need to be blasted. So it's probably a good example there. So I've got those 3 points. What do I do with them? A little bit of maths. Hopefully this isn't too scary, but we'll just do this on the fly. I add them up and I try and get to an average. So I'm going to take our worst case, which is 1 day, and I'm going to add it to our 3 days. But because this is most likely, if you think of all the instances that happen here, there's a greater chance of it happening somewhere around here. So we put a kind of weighting, and I'm going to go 4 times our 3 days, and then I'm going to add on our pessimistic. Because it's an average, I'm going to divide it over 6. If you think about it, there's 6 factors, 1, 4, and another 1 makes 6. Quickly, this is 12 plus 1, so that's 25. 25 over 6, 4.2. 4.16666 for the super nerds. So I'm going to say 4.2 days is going to be my most likely. And that's what I'm going to use in my estimate. Pros of this, I can say to the client, look, if they come to me and say, how'd you get to this number? Okay, we took the worst case, we took the best case, we took normally what it takes us, we considered all the factors, and we've used this to distribute it and to work it out. Normally this just confuses them sufficiently and they say, yep, you've put some effort in this, let's take it as legitimate. So this is a good way to increase the accuracy of your estimate without going too far into this, hey, what value am I getting out of it? So that's the 3-point estimation technique. It works just as well in cost. Instead of using days, using coin here. Cool. Hope that helped.